Welcome to Complexity Made Simple. My name is Paul Allen, and this video newsletter is specifically made for all the innovators wherever you may be whilst we are all locked down. This is the perfect opportunity to learn new skills, to go and research new things, so that when we're all back to normal and the economy across the world is booming, you are ready to make pots and pots of money. And the tool I want to talk to you about as an R&D specialist, as an innovator, is the best tool in the world: design of experiments. This is the tool you should go and research whilst you are off and you have time and volumes are low and you've got the time to do this. Design of experiments. If you've never heard of this thing, you are missing out on one of the best R&D tools ever invented. By the way, 100 years old, this thing. It is mathematics that was invented when testing and the speed of testing needed to be as fast as it could possibly be. The alternative way for this, the alternative phrase for this is the fastest way It's the fastest way to find out. You're doing innovation, research and development. You need a technique which is the fastest way to find out. Now then, let me talk to you about the complexity of your processes and why you cannot use your skill or indeed your computers to do this. You need clever ways of testing, and that's what design of experiments is. It's a clever way of testing to learn the most and to learn fastest. Now I'm just going to give you a little example to show you how this thing works. I recently had an email from a research student at a university in the United States. This engineer, what he was working on, very simple, he was working on a 3D printer. And he sent me a message and he said, "Oh, I'd like to do some tests on a 3D printer. Is this the right test I should do?" And I gave him a little bit of advice. But this is a great example. This is a new piece of technology. It's been around now for probably 10 or 15 years, but recently everyone seems to have a 3D printer nowadays. So it's become technology that everybody's using. But he wanted to know how to get it to work the best settings. That's what this thing is going to do. It's going to find you the best settings. And he just had 3 variables that he wanted to test. He said, "I've got 3 variables. I've got something called the infill percentage. The next one was the orientation." So in other words, was he going to build the 3D unit as a flat item, or was he going to stand his item up and turn it around 90 degrees? So the orientation was 0 or 90 degrees. And then finally, the last variable was the nozzle diameter that he was using to lay down. And I think this was plastic, by the way. So he had nozzle diameter. He had 0.2 of a millimeter up to 1 millimeter. So this is really easy. By the way, the infill percent, he was going from 5% to 100%. Now this looks like a relatively simple thing to do. This is new knowledge, so it's a new piece of machinery that you've just bought. Everyone seems to be using them. How do I figure out how the bloody thing works so I get the best settings? Now the variable that he was interested in, that he was trying to optimize, was the surface finish. Okay, I think he called it surface roughness, but I'm going to call it surface finish. Now he just gave me one output in this case, but there'd be others, wouldn't there? There might be the weight of the item. There might be how fast you make it, speed. And of course speed tends to be related to money. Weight tends to be related to money. And now what you're looking for is, you're looking for a sweet spot. What's the best place to put these three to hit the sweet spot? Now look, you're all R&D experts. Tell me how you would do this. Send me a message attached to this video. Tell me how you would do this, because I know how to do it. By the way, I'm not a 3D printer expert. I just know this technique, because what DOE would tell me is I only need 8 tests, and I know exactly which 8 tests I'm going to do, and then I'm going to find the answer to that. Now ask yourself this question: do you have that skill to do that? With any process, by the way, not just a process that you know, but with any process. This tool can do this. Now in this case, look, if I multiply the combinations, I've got 95 choices here, so I can take this from 5% up to 100%. So I've got 95 choices times the 2 orientations, multiplied by, what would this go up in, 0.1. There's about 8 choices on the nozzle. That comes to about 1,500 ways of setting the machine up. I'm just going to test 8 of them, and I'm going to find the answer. That's the power of this thing. This is what research and development is like. New knowledge, new processes, don't really know how they work. You need a tool to interrogate that design space. Now I'm going to give you another one. Look, this is relatively easy. 1,500 does 8 tests. Let's give you a molding example. You have a brand new molding tool come in. You've got to find the best settings, fastest settings, cheapest settings. You want to smash the competition to pieces. How do you do this? Look at this particular molding problem. There are just 8 variables, but watch this. I want to just think about how complicated the problem currently is. Because what do we have? We have 1, 2, 3, 4, 5, 6, 7. We have 8 variables there. And you'd think, well, it's only 8 dials, it's only 8 settings. It can't be particularly difficult to find the best settings. Now I know that you can find settings that work on a machine. That isn't what we're trying to find here. We are trying to find the very best settings, the fastest settings with the best quality. This isn't about a set of settings that just work. They already have that. Okay, so we are trying to find the very best settings. So 8 variables. Now it looks really easy, doesn't it? But actually what most people do is they only count the variables. They don't look at the number of combinations. So look at this. You have 100 choices multiplied by 50 choices, multiplied by 44, by 44 choices, by 225 choices, by 90 choices, by 20 choices, by 400 choices. If you multiply that lot through, this isn't 8 variables that you're looking at. And I've just worked this out on a calculator. Oh dear. It's 1.5 trillion choices. That's the complexity of trying to find best settings. This cannot be done with someone's skill. Someone cannot carry this model in their head and understand what the best settings will be to get the fastest process with the best capability. It just is not possible. Only DOE can interrogate that design space using mathematics essentially. Okay, 1.5 trillion combinations. 1.5 trillion combinations. The DOE only needs 20 tests to find the answer to that problem. The best settings for that machine. It just needs 20 tests. By the way, they need to be the right 20 tests. Now here's my challenge to you. Innovators across the world, how would you have done that if you were invited into that molding company? Forget skill, by the way. I don't care if you've been on the machine for 30 years. You do not know where the best settings are. Cheapest, fastest, best settings. You can never know that. You'll get the process running, but not with the best settings. So, design of experiments. If you want to get my latest book, Design of Experiments for 21st Century Engineers by Paul Allen, you can get this book on lulu.com, because in this day and age, faced with new challenges that we've got today, you need the fastest way to find new knowledge. Go and buy Design of Experiments for 21st Century Engineers, or leave me a message. Tell me what is a faster way of doing this. I look forward to hearing from you.